So before I get started, I want to get to know the audience a little bit. So maybe raise your hand if you work as something other than a technical writer. Okay. Do some of those people maybe want to tell us what they do? Okay. Okay. We do a little bit of everything. Lovely. I think it's mainly JetBrains people in here, but I'll just check. Has everyone used Git before? Okay. Great. This just gives me an idea of like how much I need to explain things or how much context I need to give. So my first caveat, whoops, is that I'm not a Git expert. And the way that I describe it is I'm like a third grade math teacher. So I came up with a creative idea of how I can teach Git basics in a very simple way. But I'm not like a maths professor that can solve theorems and teach you the very, very internals of Git or go into very, very advanced topics. I just figured out how to teach the basics in a simple way. But what I discovered was that when you understand the basics and you have a solid foundation, it makes everything else a lot easier. And it makes learning whatever other features of Git you need to learn a lot easier. Um, my second caveat is that my approach to teaching may not suit everyone's learning style. So I teach in a very visual way, and kind of using some metaphors and making things tangible, but it might not be something you like. So today you're going to get a taste of my teaching approach, just to share with you kind of how I approached learning and teaching it. But it might be something that you say, not quite for me. And my third caveat is that I don't tell people how they should use Git. So I'm not at all prescriptive. I only teach how Git works, how the tool works, but I don't tell people what their Git workflow should be, what their branching strategy should be, what their commit messages should look like. Um, I just teach how the tool works, and then once you know how it works, you can implement it in whatever way you want. Usually, you should just talk to your team that you're working with or the company you're working for, and they'll have their own opinions on how they want to use the tool. Finally, I prioritize building a solid mental model of how Git works over memorization. So sometimes even I don't remember what's that option that I need to use with this command. Was it -A or -M? Or for example, here you have a literal screenshot from my history where I Googled Git rebase because I couldn't remember, do I check out the branch and then I do the rebase? Like, do I need to be on the branch that I'm rebasing or the one that I'm rebasing onto? And this is literally, guys, 23rd of February. This was last week. Not kidding. Sometimes I even open up my own book and I'm like, what was it again? I can't remember. So I really think that it's important to have a mental model, and then there's the Git reference. There's online resources to check, like, okay, what was the exact like command I need to use? So my teaching methodology is based on building a mental model, making things tangible, and making things visual. Um, and my entire kind of book is a hands-on learning experience. And this is just an example, a random example from chapter 3, which is a follow-along section. The entire book has follow-along sections. So today I'm going to be working on kind of the content in the first couple chapters. And you're going to kind of get to see what the learner goes through. But obviously, it's not going to be follow along for the rest of the people because that is very difficult logistically. So, okay, first I'm going to show you kind of my approach to how I build the Git diagram, which is kind of the foundation of the mental model that I build. Then I'm going to show you kind of how I teach people how to make a commit, but then how that process interacts with all the aspects of the Git diagram. And then in the third part, I'm going to just touch on branches and how I introduce branches to people. So first of all, when I started learning Git, I came across this diagram or versions of this diagram. And I personally found it really confusing. I didn't quite understand exactly how all these pieces came together. And so what I'm about to show you is my alternative to this and what I came up with instead. And throughout the book, I call the visualizations visualize it. So in this presentation, they're called visualize it as well. Okay, So I'm going to make this a bit smaller so we make some screen space for other stuff. So the first thing I want to talk about is visible files and hidden files. So I'm assuming most people here know already. Let me just get my terminal open as well. That your computer has visible files, so files and directories that you're able to see, so all the ones here, but that there's also hidden files. And those are only visible on a Mac. You have to press Command-Shift-Dot, and you see all these hidden files, which I didn't know before I had to start learning Git. And I'm assuming everyone's kind of familiar with the command line, so I won't spend too much time talking about what the commands I'm about to use are. But basically, to list visible files in the command line, we use ls. And then to list visible and hidden files, it's ls-a. So this becomes important later on. All right, so the first thing we want to do is we want to actually make the project folder that we're going to work on to learn kind of the basics of Git. And what I do in the book is we create a project folder called Rainbow. So I'm going to do that, and I'm going to go onto the desktop so we can see it being created. And then here I'm going to use a command called mkdir and make a directory called Rainbow. And I'm just going to go here as well so you can see that. Here we go. Okay, so this is the project folder, and this is the first thing I'm going to add a representation for in my Git diagram. So this represents my project directory. Now, the next thing I want to do is I want to go into this project directory, and I want to see that actually there's nothing in there at the moment. So if I do ls, I can see that there's no visible files in this project directory. And if I do ls-a, there are no hidden files either. And this is about to change because we're going to do the very first step, which is to initialize a repository. So to initialize a repository, I'm going to type in the git init command. And what this command is going to do is it's going to create a .git directory inside my project directory. And that .git directory is basically what represents the local repository. So I'm going to press enter, and you can see that now that .git directory was created. And I add a representation for that in my visualization. It took me a long time to realize that this .git directory existed. So for me, it was a real breakthrough moment when I discovered this. So there's 3 more sections of my Git diagram that that I include. First of all, it's the working directory. So in the project folder, the working directory is basically where you add, edit files, delete files. And I kind of explained that it's basically everything in your project folder except for the .git directory. So when I add a representation for it in the diagram, it looks like this. So this is the working directory. This is the local repository. And then there's 2 more areas. There's the staging area. So the staging area is inside the .git directory, and it's represented by a file called index. But this file doesn't exist yet because it's only created once you add the very first file to your project, to the staging area. That's when the index file is created, so we'll see that later on. But I add a representation for it here in the diagram. And then finally, the last area of Git that I include is the commit history, which is basically represented by the objects folder. And I include that here. So for me, it was really important to make these things very tangible and be able to see like the .git directory, the index file, the objects folder, and what they represent. I guess everyone here kind of knows what a commit is. It's a version of your project. So I won't get into that. And every commit has a commit hash, basically 40 characters, or like a unique name for the commit. So we've created the Git diagram. This is what it looks like in the book. And the next thing is to just kind of show how the process of making a commit interacts with each part of that commit diagram so that a learner can have a good idea of kind of how this mental model works with the commit making process. So in order to do that, we're going to actually add the first file to our project. And for that, I'm going to use IntelliJ IDEA. So let me just open up IntelliJ, and I'm going to open the Rainbow folder. Okay, there we go. This I'm going to put down here. Let me just do some screen management here. I also don't know. It's all visible, right? It's everything's big enough. The font. Okay, amazing. Great. So give me a second. This is okay. So normally at the moment there's this .idea hidden directory. Ignore that. That's just something with IntelliJ, but that's not something we're going to touch upon. So the first thing we want to do is we want to add a file, and that file is going to be created in our working directory. So I'm just going to use IntelliJ to add the first file to my project. So I'm just going to call it rainbowcolors.txt. And ignore this as well. Normally, we wouldn't get that if you're using any other text editor. So, and I'm going to add some text. So red is the first color of the rainbow. So we've added a file to our working directory, and we can see that in the diagram. And we can see it here as well in our file system. But that file is not yet part of our repository. We haven't added it to the staging area, and we haven't included it in any commits. And one command we can use is git status. So this is a command that basically gives us the state of our working directory and the state of our staging area and the difference between the two. So here we can see it says untracked file, which basically means this file is not yet being tracked by Git. So now we're going to do the first step basically of making a commit, which is to use the git add command and add that file to the staging area. And we're going to pass in the name of the file. And what I mentioned before is that the index file is created when you add your first file to your project. So we're going to actually get to see that index file being created inside that .git directory once I execute this command. So git add, and then now you can see index was created. So that's your staging area, or that's basically kind of what represents the staging area. So to update the diagram, we've now added the file to the staging area. A common misconception is that the file was moved from the working directory to the staging area, which when you think of that other diagram I showed you where it had like the arrow kind of pointing from the working directory to the staging area, I think that diagram really causes that misconception, but actually the file isn't moved, it's just kind of copied over. And that's why if I make any updates right now to the file, I need to add the updated file to the staging area. So the final stage is just to make the commit basically, which most people know, git commit -m, which stands for message, and then we're going to pass in a message. And basically, I use colors throughout my teaching approach. So I'm just going to give the commit message of the color that we added to our project. So that's red. And press enter. And now we've made our first commit, which I'll represent in the diagram. So this is the red commit, and we can use the git log command, which basically is a command that lists all your commits in reverse chronological order to see this commit. I think, is that big? Yeah, it's big enough. So we can see that we have the commit hash, which is that unique name for the commit. It says who committed it, when it was committed, and then the commit message. Okay, so that was basically the process of making a commit and using the Git diagram in order to show how that process interacts with each part of each area of Git, let's say. And this is what it looks like in the book. And finally, the last part I wanted to go over is basically how I introduce how branches work. So we've got this commit here, and we can see that it's got the commit hash, the name, the date, but there's this content in parentheses. And basically main is a branch. And what is a branch in Git? Quick note, this is the Git diagram, and then I have another diagram in the book that I call the repository diagram. And what we're basically going to do is we're going to basically zoom into the commit history and only look at that so that we can simplify everything else. So this is what the repository diagram looks like. And what we have right now is the red commit. And the way that I explain what branches are is I just say they are pointers to commits. So the way I make that really explicit is I'm going to show you that inside the refs directory, inside the heads directory, there's a file called main. And if I open up this file and I make that a little bit bigger, we can see that inside that main file, there's a commit hash. And that commit hash is actually just the commit hash of the red commit. And that's how I show people explicitly that branches are just pointers to commits. They just point to a specific commit. So if we now just add some more content to our project, so orange is the second color of the rainbow. And we add the file to the staging area. And we make a commit with the commit name of the color that we just added. Then if I do git log, we can see that the branch has updated to point to this commit. And we can explicitly see that because now the commit hash in that main file has updated. So we can see that now main is updated to point to the orange commit. And then just a quick note about the relationship between commits. So we can see that orange is pointing back to red. And that's because commits, orange is the child commit of the red commit. And to see this explicitly, we can use a command that you will never use in real life because you don't use it in your day-to-day, but it's really good for teaching purposes. And it's called git cat file -p. And I'm going to pass in the commit hash for the orange commit. And here we can see that it literally tells us that the parent of the orange commit is this commit, which is the red commit. So Git will tell us everything we need to know. And I think it's really important to be able to know how commits are kind of linked to one another to understand like the diagram. Okay, so we saw how a branch progresses once you make a commit. Then the question is, how do I make new branches? Well, we can use the git branch command and pass in the name of a branch that doesn't exist yet. And what will happen is when we execute this command, you will see another file be created in the heads directory called feature. And that will represent the new branch because branches are just pointers to commits. So git branch feature, feature. And again, it just has the commit in the file. So if I do git log now, we can see feature main point to the orange commit. Okay, we've made a new branch. Now the final question, the thing that we can see in the git log output that we haven't quite explained yet is head in capital letters. So what is head and why is it pointing to main? We can explicitly see this in the .git directory. So there's a file called head in capital letters. And when we open up that file, we can see that it's a reference to the main branch. So head is basically just a pointer or a reference to the branch that you're currently on. And the way that I show that in the diagram is I just have another pointer pointing to main. So even though we made the feature branch, we're not actually on the feature branch. And to switch to be on the feature branch, we can use a command called git switch. We can also use git checkout, but git switch is the specific command for it. Pass in the name of the branch that we want to switch onto. And now we can see that if we open up the head file again, now it references the feature branch. So Git will tell you everything you need to know about what's happening. And now we can see that it's switched to the feature branch. And if we do git log, we can see that head now points to feature. The final thing we can do is just make another commit and see how that's going to affect our branches. So yellow is the third color of the rainbow. And then just git add rainbow colors.txt commit -m yellow. I do everything explicitly. Obviously, you can do shortcuts. But here we go. Now we can see that feature has updated to point to the yellow commit. And to represent that in the diagram, we can see it like that. So was probably a lot of revision for everyone. Probably everyone knew a lot of this stuff, but this basically gave you a taste of what my Git teaching approach is. It just breaks down everything and makes it all very tangible. And for someone that is either at the beginning of learning Git or doesn't have a good mental model of how Git works and how the pieces come together, I found that for a particular type of learner that is like myself, making things visual and making things tangible and going inside the .git directory and looking at the exact file that represents the thing I'm trying to look at really helped me. And yeah, that's basically it. So this is, by the way, what the repository that you work on throughout the book looks like at the end of the book, where you've worked with a friend. So you've got two local repositories, and local repositories are represented by rectangles with 90-degree angles. And then you also have a remote repository that you've worked with, which I represent remote repositories with rounded angles. And obviously what we went through today is the first couple chapters, so it's the easier stuff. But once you get into three-way merges, merge conflicts, rebasing, things get a little bit more tricky and a little bit more, spicy. So yeah, that was it. That was kind of my presentation, just to give everyone a taste. But yeah, we can talk about other things later as well.